Hi everyone and welcome back to Exception Handling. Here I have a class called Exception Handling and I've got the main method in here. Let's just go ahead and let's say create a method. So that would be public static void foo. I need to make it static because I'm going to call it from main. I take two integers here in A and in B, and what I do within this is something like try um, in C equals A by B, and okay, let's just see what happens now. Actually, let's just first see what happens if I just do something like this. I make this without um, a try catch block. I do a Java C exception handling dot Java, and then I do Java exception handling. Okay, I forgot to call the foo method, so I call it with foo 5 comma 0. And let's just go ahead and compile again. So it says exception in thread main java.lang.arithmetic exception division by 0 at exception handling dot foo, and it's giving me the line number 8. So that's the line inside of foo where my exception has occurred. And then it says at exception handling dot main which is at java 4, so that's line number 4. So that's this line right here where I called foo. So that's the stack trace that I was talking about. So let's just go ahead and clear this and let's create the try block once again. So I put this within a try, and let's try compiling it again. It says error try without catch finally or resource declaration. So basically it's saying that you don't have a catch corresponding to this, so I'll have to create that. So catch arithmetic exception E, and inside this catch block, let's say I do a system dot out dot println, and I just say invalid parameters. So let's try compiling it again, and if we run it now, it says invalid parameters. So that's because it went here and then it realized that it cannot do this A by B thing. I could actually add a system dot out dot println and do try block, and let's see what happens now. So it says try block and then invalid parameters, which means that it actually enters the try block, it executes this line, then it tries to execute this line and then realizes that this cannot be done and jumps here. So if I add something like system.out.println here and I say division success, and let's try to do this again. Once again, it just says try block and invalid parameters. So it skipped doing this because it encountered an exception here. So that's what's going on. And I can also add a finally block right after this. And here I just, let's say, do a system dot out dot println, and I just write finally. Um, and let's compile again, and here now it says try block invalid parameters and then finally. So it basically encountered an exception and then went to the catch block and then to the finally block. And just to show you that this will also work if it did the try block correctly, let's do something like this. and now it says try block division success, and then finally. So the finally block is executed no matter whether the program goes into the try block or the catch block. So that's what's going on here. And let's just do something else. Let's get rid of this, and let's just create an instance of the exception class and throw it. So we do a throw new arithmetic exception, um, and let's just clear this and compile now. And it just stopped execution of the program. So it just says that 20 I encountered an exception, that was this one which was thrown, and it was caught right here. So I could also do it within the catch block itself. I can just do a throw here instead of this system.out.println. I could do a throw e, let's say, and if I do it again, I expect actually it didn't enter the catch block at all, so I need to make this 0. And now again it went into the try block, it went into the finally block as well, but it says that exception in thread main, and it points to this line right here. So that's where the exception occurred. Then it went to the catch block, and then it threw the exception right here, which is why the program terminated. So if I want to stop this from terminating, I should do something like try foo, and after I've done that, I catch exception e, and I just do a system.out.println failed. So now I could actually, instead of throwing e, I could also throw something like a new exception, and let's just go ahead and compile this. Alright, so what it says here is that error unreported exception must be caught or declared to be thrown. So what that means is that it needs to know that I am going to throw this exception. And the reason why I didn't get this error before when I was trying to throw an arithmetic exception is because an arithmetic exception is an unchecked exception. So I'm allowed to do a throw with an arithmetic exception, but not with just exception. So what I need to do now is just use the throws keyword, throws exception, and let's try it now. Let me just clear this, and now it compiles correctly. And if I do it now, it says try block finally and then failed. So it went here, it executed this line, then it came here, realized that there was an exception here, so it skipped to the catch block, and here I just said throw new exception. Before it went back to the main, it knows that there's a finally here, so it goes into the finally, executes this line before exiting this method, and then it goes back to main, and within main I did a try foo, and I did a catch exception e, and then a failed. So that's what it did, because it got an exception in foo, it printed out failed. So that's what's going on. Also, we can actually have multiple catch blocks corresponding to a single try block. So let me just do something like arithmetic exception here, and I'll just print arithmetic, and then I do a catch and exception e, and I just do a system.out.println, and I print exception here. So I've got two catch blocks corresponding to the same try block, which catch different types of exceptions. And let me just go ahead and compile this now. I'll clear this once, and then I do this. So it says try block finally and then exception. So what happened here was that after this exception was thrown, it went to this catch block, but this one accepts an arithmetic exception. So it went to the second catch block. This one expects an exception, and that's what it got from foo. So it executed this line right here. Instead, if I do something like arithmetic exception here and I compile it now, it says try block finally and then arithmetic. That's because it entered this catch block. Also, let's just try flipping these catch blocks. So I do this now, and let me just clear this. And alright, so what it says here is it has an error. It says exception, arithmetic exception has already been caught. So the reason behind this is because this part right here is dead code, because exception is the parent class of arithmetic exception. So even if this actually did have an arithmetic exception, it could actually go to this catch block, and arithmetic exceptions are handled here. So having this code here is actually redundant. It's never going to reach this part of the code. So this kind of code is called dead code. So it gives you an error. It gives you a compile time error in case of dead code. So what we must do to avoid errors here is to have the catch blocks with a more specialized exception first, and then have the more generalized exception. So let me just flip this once again. And actually this isn't really related to exception handling, but since the topic of dead code has come up, I just wanted to show you something else. Let's say I do system.out.println and I do foo, and then I do a return, and then I try to do system.out.println, and let's say I print something else. I print returned, and if I go here and try compiling it again, it actually says error unreachable statement. So this line right here is another example of dead code. So it gives you a compile time error in case of dead code. So I think that's it about exception handling. I'll need another programming session, I guess, for exception handling, because one important aspect of exception handling is creating our own exceptions, because finally the exception class is a class which we can actually inherit and make our own custom exceptions, and that's a really important thing. So I'll see you in the next video then.